So good morning. I'm Daniel Hastings, the current head of the MIT AeroAstro department. Today we celebrate the 64th anniversary of the first Lester Gardner lecture given in 1959. The Gardner lecture was made possible by the bequest of the late Major Lester Gardner, a member of the MIT class of 1898, to sponsor annual presentations on aeronautical history. So we broadened it to aerospace. Over the years, we've been honored by luminaries such as Igor Sikorsky, Jimmy Doolittle, Yvonne Brill, Neil Armstrong, to name a few. A remarkable individual, Major Gardner played several critical roles in the advancement of aviation in the early years of the 20th century. He actually, with the encouragement of Grover Loening and Jerome Hunsack and Glenn Martin, he organized the Gardner Publishing Company, which published Aviation Who's Who, which later became Aviation Week, which some of us read every week. In addition, he was the founder of the Institute of Aeronautical Sciences, which later became the Institute of Aerospace Sciences, which became the AIAA. So he had his hand in two very big things. He was an air officer in World War I, the recipient of numerous aeronautical awards, including the Daniel Guggenheim Medal in 1947. He was always interested in MIT, which continued throughout his life, and he helped establish this Gardner Lectureship as well as the Hunsaker Professorship. With that as background, I want to turn our attention to our speaker today, Colonel retired Pam Melroy, who is the NASA Deputy Administrator. Now, Pam asked that I keep her CV very short. Okay. So what can I say about Pam? She's flown many aircraft in the Air Force. As Deputy Administrator, she performs the duties and exercises the powers delegated by the Administrator, assists the Administrator in making final agency decisions, acts for the Administrator in his absence. She's also responsible for laying out the agency's vision and representing NASA to the Executive Office of the President and Congress, and so on. She's been an astronaut, has flown in space 3 times, right? 3 times, right? Flew the shuttle up in space, helped assemble space station, and has worked with DARPA, Lockheed Martin, a number of other places. But most important, she's a graduate of MIT. And we're very proud of her. So with that, Pam, it's up to you.
Thank you so much. It's really wonderful to be back at MIT, and I really appreciate that brief introduction, Dan, who is a treasure. You are a treasure. I've enjoyed so much working with you in the private sector as well, and thank you for your leadership of the AeroAstro department. I do have to let everybody know that I actually got my degree in Earth and Planetary Science here, not in AeroAstro. But I think, most of my career was spent doing essentially AeroAstro engineering. So I'm really happy in the position that I'm in now, that I have the opportunity to have the science background to work with the Science Mission Directorate at NASA, as well as feeling very comfortable with both aeronautics and space technology. So I've really been able to achieve a lot of my dreams as a result of the work that I was able to do here at MIT. And so, extraordinarily impressive department and activities going on. Loved the Pitch Fest we just heard. It was very impressive, actually, having heard a lot of those things. There are so many things I could talk to you about today, but I decided to pick something that I think is extremely important and perhaps provide a little bit of context around that, and that is our Moon to Mars strategy. I'm hoping to talk for a little while, but I'd also like to have a dialogue. I want to take your questions because we have so much stuff going on at NASA right now. I won't come even close to discussing a tenth of it, but to me this is very important. It's a critical aspect of what we're doing. So I do want to give a shout out to MIT. Many of you maybe have seen this picture of Margaret Hamilton, who was the lead for the guidance system development software for Apollo. and she was right here at MIT. And in fact, it's just fascinating as we go forward with Artemis to realize essentially software engineering was invented by Margaret and her team. It just didn't exist as a discipline before Apollo. We needed that. It's a great example of how the technology investments that we make when we do hard things actually spill off into other areas. I think everyone's familiar with Buzz Aldrin's thesis and the work that he did as well, but I just want to make a special shout out to Margaret because she's near and dear to my heart. The fault detection, isolation, and recovery algorithms were absolutely critical. You all probably heard the, we're all turning blue down here, kind of thing, the overflight for Neil Armstrong. But in fact, what was happening was that the nav system was, had a massive stack overflow. But Margaret's algorithm enabled the flight to keep going because essentially it dumped the stuff it didn't need. It had a list of the things that it absolutely had to have. And then every time the computer reset, it carried over the critical data to the next level, which allowed that flight to continue. So really, truly extraordinary work there. So I hope you had the opportunity to watch the Artemis launch, either real time and live or after the fact. It was really impressive to be there. One of the things that's interesting about launching a rocket for the first time, it's not just about the technology, it's about the operations as well. And so for us to figure out signatures that we were seeing as we got close to launch countdown, making sure that we understood what was happening to the vehicle, it took us a couple tries, but we were thrilled. And the performance of the rocket was absolutely incredible. And one of my favorite pictures in the upper right corner, I think we're all used to seeing digital images where people stack, several complicated things together. That is actually not stacked. That is a selfie in the upper right corner from the solar array of Orion. So at the tip of the solar array was a camera, and pointing back, yes, that is the moon, and beyond it, the Earth. And that is a real-time photo that was taken. That was just, I think, phenomenally inspiring for all of us to see real live photos from the moon for the first time in more than 50 years. So really, really phenomenal. So we're at a very, very special place in time. We've spent the last decade of investments to get to this point in having the transportation system that will enable human beings to go to deep space. I'm going to be very, straightforward about this. It has been a tough decade for NASA. It's very hard to go into tech development because you're not flying hardware. So people are like, where are we? What's happening? There's nothing happening. And in fact, space, the investment takes a long time to get to this point. And the first test flight was absolutely phenomenal. As a result of that, there's been changes in space policy and discussions about what our destination was going to be that have had an impact, I think, on all of us. So NASA took an approach which I really was very supportive of, which is capabilities-based approach. We're going to build the capability to send humans into deep space, and then wherever anybody decides to send us, we will be ready to do it. But I think we're at a different place right now, and especially with the announcement that we made on Monday of the Artemis II crew, so the first crew that will go into deep space in more than 50 years. Really extraordinary. It's getting real. It's getting very real. So we hope to fly that mission by the end of 2024. Right now, the long pole in the tent is actually refurbishment of electronics between Orion 1 and Orion 2. So all those electronics were pulled a few days ahead of schedule, actually, and they are now at the vendor for evaluation and understanding. But some basic things like the fact that we didn't get saltwater intrusion inside the vehicle and things like that give us hope that we'll be able to stick to that schedule. The next long pole in the tent, there's a couple pieces of the SLS manufacturer, but I was just there last week at Michoud and saw the Artemis II vehicle getting very, very close. So I think we're, in pretty good shape. Just like in Apollo, we've got thousands of people involved in this and thousands of people invested in it. One of the things that is unusual is, and very different from Apollo, is that we were very focused on going together internationally. So Jeremy Hansen, one of the crew members, is from Canada. There could be no more visible representation of the difference between Artemis and Apollo than this crew. First of all, we have a woman, we have a person of color, we have a person from an international partner. So it's very different, but it's highly appropriate because Apollo, after all, the mission was to send a man to the moon and return him safely. That was it. What we found when we got there was all kinds of really interesting science and other technology spin-offs as a result of that. But really, in the eyes of the public and the stakeholders, that was the mission. We've got a different mission now. Artemis is a very, very different purpose. It's actually about going out into deep space with humans to stay. And so I love this picture just because I think it's a critical part of the story. So, and we're starting this year. We're not waiting. Capstone is in the near rectilinear halo orbit that we plan to put Gateway, which is our orbiting logistics cache and technology demonstrator and potentially a jump-off point for Mars that will be put into orbit around the moon. The problem is it's a very complicated orbit. It's really interesting being an astronaut because I have a strong intuitive sense of low Earth orbit mechanics. I mean, I just lived it. Had to fly 3 rendezvous and dockings and undockings with the space station. So it's just something that I really, really understand. I'll tell you what, I have been struggling with the astrodynamics around the moon because it's really a 3-body problem. So much influenced by the gravity of the Earth, but also much more influenced by the gravity of the Sun. So fantastically challenging, especially as you look at our destination for Artemis is the South Pole, much more difficult than getting to the equator. One of the benefits of the NRHO orbit is that it will ensure that we have 100% comm coverage at all times for the crew, which I think is really important. One of the things that was very interesting about Apollo, if you go back and talk to those folks, how they sweated it when the crew was on the far side of the moon and how little, information. There was no information, especially when you're making critical burns like the burn to get back into the trajectory back to Earth. All happened on the far side of the moon. So Capstone is providing us really critical information about that orbit right now to really understand the dynamics better. I mean, we certainly got the theory. We know a lot about the Earth's gravitational field from all the satellites that have been operating here. It's a lot more complex with the moon, and in particular, that 3-body dynamics. So that data is going to be critical because it will help us operate Gateway more efficiently. And then this year, we'll be landing through the commercial lunar payload services, multiple science and technology payloads on the surface of the moon, many of them to support important decadal recommendations around science, but many also to pave the way for Artemis and for crewed missions, because we really want to be doing science and technology with our astronauts on the surface of the moon. That's what they do best. So this is, very exciting. I think from my standpoint, the more hardware we can see on the moon as early as possible, that is actually also very helpful for all of us. First of all, it paves the way and helps us understand what we're going to do. But I think we can also send a very different message to all of our stakeholders, which is we're here to stay. This isn't just a camping trip, boots on the moon, and return home. So I'd like to talk about the moon for a moment. One of the things that we like to say is 50 years ago, we went to the moon, so what's different? Well, first of all, the moon is different. I talked about going to the south pole of the moon. So the previous exploration of the moon was all in the equatorial region. And of course, the south pole of the moon is a very interesting place. The technology and the science demonstrations that finding out that in the deeply shadowed regions of the South Pole, we have the potential to find water. We still don't know how much exactly or where the optimum places are, so we really have a lot of work to do there. But it's very different geologically, and it's a very different place from any place that we've ever explored before. Then you add onto it that we're different. our technical capabilities, the things that we know how to do, the science that we know how to do, and the exploration is completely different. We have learned so much. I mean, if you look back at the history of the space shuttle, we had the opportunity to fly an orbiting laboratory and also manufacture a space station, repair the Hubble, and deploy it, of course. But we learned a lot, but it was a tantalizing amount of science that we got out of the space shuttle. And if you're going to operate a national lab only about 6 times a year for about 10 days to 2 weeks at a time, sooner or later, you're going to decide you need more science, more data. And that's why we built the International Space Station, so that we could do science 365 days a year. But in addition to that, we learned how to sustain and support humans and the science that they are doing for much longer periods of time. And that is absolutely critical as we go out into the solar system. So our capabilities are not the same. What we have learned is not the same. It is, in fact, a new moon. One of the things that I get asked a lot is, please help those of us who intuitively know why space is important and why space exploration is important. How do we explain that? How do we explain that to the average American or indeed the average citizen of Earth? So together with our senior leaders at the agency, we put together this why chart, and it's the structure is around explaining some of that. So I'll start with science front and center, and I think that's critically important. Science is the seed corn for our technical capabilities of the future. We all understand that. The scientific research that we do today leads to technological breakthroughs in 10, 20, or even 50 years. And that's very, very important. So it is the seed corn. We can get unique science from space that cannot be done anywhere else. One example of that, great example, is the James Webb Space Telescope, operating in frequencies and at levels of sensitivity not achievable here on Earth. There is no way that we could look back in time to just a few 100 million years after the Big Bang and really understand the formation of the universe without going to space. But in addition to that, especially as we've seen on the shuttle and station, is the microgravity science that we do gives us amazing insights into biological and physical sciences. It's extraordinary when you take gravity out of the equation, the second and third order effects that we have learned that will enable us to do things like have more efficient fluid flow and combustion here on the Earth, the insights into the human body. Why is it that our astronauts are dehydrated, but they are not subject to substantial higher percentages of kidney stones, is a great example of the kind of critical research that we can only do in microgravity. And of course, there's no way to look at the Earth as a system except from space. You simply cannot get enough terrestrial sensors to understand what is happening to our climate. And in fact, 80% of the data that we use to understand climate change and what's happening to the climate comes from space. If we're going to have a prayer of measuring the impacts of the things we hope to do, we have to do it from space. Science is front and center. Second, national posture. That's a big umbrella. It can talk about things like national geopolitical posture, but I think more importantly, it's the capabilities of a country to do science and technology. So I mentioned Margaret Hamilton in software engineering. There's multiple other examples. I think most people are familiar with at least one spinoff from NASA, the camera in your cell phone, which was developed to put a camera on a chip for Earth sensing. There are so many examples, there are countless examples, but the point being, as President Kennedy said so many years ago, the point is to do it because it's hard. And so when we do hard things, we lift the technical and scientific capability of our country to attack multiple problems. And increasingly, with a growing commercial space industry, the economic impact is significant. This is a high-tech, high-growth industry. And all around the world, countries are starting space agencies because they don't want to get left behind on the impact of space. And in fact, space is impacting so many other industries now: agriculture, maritime, homeland security. I often speculate that 35 years ago, there were a lot of people saying, well, what is this internet thing, and will it really have an impact on my industry? I think in 30 years, we will not be asking a question about what the relevance of space is to other industries. And finally, inspiration. It's the way you feel when you see that picture from the James Webb Space Telescope or the Hubble Space Telescope. But importantly, this is attacking the other issue, our other seed corn issue, which is the pipeline of STEM students for the future. Space really plays a unique role in inspiring people, making them think about their place in the universe, but also providing excitement and relevance for problems of the future that focus students on investing in STEM. So these are the three buckets, if you will, that I think are absolutely critical. So when Administrator Nelson and I came to the agency, I was spending a lot of time thinking about our Moon to Mars strategy. And maybe it's because I was a physics major, but to me, these are our first principles. Anything we build in a strategy has to address all three of these areas. And the reason is that as I go around the world, I often meet people who only care about one or two of those buckets. They don't care about all three. Some do. What that means, though, is that if we don't have a strategy that addresses all three areas, we are missing key stakeholders. And if you want a politically resilient approach to human spaceflight and exploration for the future, you're going to have to hit all three of these things and stay laser focused on it. So you may have heard a lot of arguments. Maybe you've proposed them, and I'm happy to discuss them. And that has to do with what are we doing? So there's, you hear all kinds of things like, well, we should be just doing science and we should be doing it all robotically. That's, more cost effective. I've also heard, why do we need Gateway? Why don't we just go to Mars first, et cetera, et cetera. Well, we don't have a decadal survey for human spaceflight the way science does, where you gather input from the broadest set of communities about what it is that what are the critical science questions that need to be resolved. So when I came to the agency, I brought us all together. I found an organization that was made up of the highest technical leaders called the Federated Board and said, okay, we've done a lot of work on this. We actually know what we need to do to get to Mars. Let's talk about it. What capabilities do we actually need to develop? And by the way, what are we actually trying to do? So this is the challenge that I gave the team. I said, I want us to create a blueprint for sustained human presence and exploration throughout the solar system. It's really important. I think if you ask the average American, what is the job of NASA? That would be it. This is what we've all been waiting for, right? We've got to figure this out. And we need to develop that blueprint by practicing it on the moon so that we can then go demonstrate it on Mars and then go on to the next destination after that. So every single word in that statement means something very important. I'll start out with talking about science. So sustained human presence, why is that important? Well, as we have learned from the space station, having science 24/7 is actually the best way to get your return on investment. So it's okay if we're going to go to the moon. It's a 3-day trip or so, maybe a week, spend 30 days doing science, and then 3 days coming home. That's actually not a bad return on investment. Anywhere else in the solar system, the numbers get really bad really fast. So even Mars, at the best that we can hope for, 6 months there, 30-day stay, probably about a 9-month trip home, you're kind of looking at a 2-year trip for 30 days of science. Now that's okay for a test flight, but that's not actually how we are going to get the maximum science return. So we really need to think about how to get a sustained presence. And we need to be incorporating science from the very beginning. The extraordinary knowledge that we gained from the samples of the moon that our Apollo astronauts returned, that was not the original purpose of that program. It was just to go and come back. But it was incredible. I mean, those samples are unbelievable in what they've taught us about the history of the Earth, the history of the moon, and the history of the solar system. So we really need to be incorporating science front and center, and I'm really excited to say that everyone is on board with that, and we're making significant progress in that area. Transportation and habitation, that's the one we've made all that progress on in the last 10 years. But we have a lot more to go. We need to be looking at transportation systems on the surface of the moon. When I talk about maximizing science return, one of my favorite statistics is actually not that long ago, I think it was about 4 or 5 months ago, the sum total of the distance traveled by all the rovers on Mars finally exceeded the last 4 missions of Apollo. So finally, after 25 years, and those 4 short missions to the moon. When you send humans, they bring transportation, they bring a lot of power, and they bring this, your brain. So we can get a lot more science by using human-machine teaming, but they have to have the ability to get there and to stay alive and to be transported around. Infrastructure. So my point about humans doing science in space long term, we have to develop the human infrastructure to support humans to stay for longer durations in deep space. NASA needs that. If we're going to get the science return on investment, we have to have the communications backbone. We have to have the power. We have to have landing sites. We have to have all of the things that support humans for a long period of time. But excitingly, here on Earth, infrastructure enables new business models. We see that every day. It's not just roads, our aircraft system. In addition to that, of course, the internet is a key piece of infrastructure. Our power grids, all of those things enable the business models around us. So if we make the investments in demonstrating scalable and cost-effective infrastructure to support humans, we know the economic business will follow us. And finally, operations. Greatly overlooked, not by me as an operator. I lived through the transition between operating the space shuttle for short duration missions and the transition to long duration missions on the International Space Station. Very, very, very different. We had a lot of things to learn about human health and performance and how to optimize our operations. We're going to have to start all over from scratch doing science on the surface of another celestial body. We have much to learn in operations. So when I challenged the Federated Board, they brought together a set of objectives in these 4 different buckets. And they said, what do we need to learn, understand, and prove to be ready to go to Mars? So I think it's really important to see that this actually transcends a lot of the arguments in a lot of ways. We can show that we have a very clear path from the moon to Mars as a result of these objectives. Just like to talk for a moment about science and human-machine teaming. To me, this is actually a very, very exciting new technology area. I've been interested in it since I worked at DARPA and even before. The concept that we are actually going to maximize the capability of our to do exploration, but also to do science by the right optimization. And we all know what machines are good at, and we also know what humans are good at. Probably the toughest technical problem of all is figuring out how to partner them and how to create an architecture that actually leverages the capabilities. I think we just barely scratched the surface, but it was very exciting for me in the last planetary decadal, where they proposed a mission with a little rover on the surface of the moon going around a crater on the South Pole and picking up geological samples from multiple areas that we know from remote sensing, have very interesting geological properties, and then delivering them to the crew for return. Now, the astronaut crew said, wait, we're scientists too. So one of the things that I think we need to look at is how to maximize the human element as well. I mean, it's great. Let's get 10 times as many samples as we actually have room to come home, and then give our astronauts handheld tools. Maybe they'll be using a helmet visor eventually on Mars, maybe with operating a helicopter for remote sensing as well. But the idea being that we can use humans to select the right sample. So I have this dream that there's a scientist looking through the helmet visor, looking at the samples with handheld mass spectrograph, and et cetera, and then everybody in the back room jumping up and down and saying, bring home number 7. That's the sample we want. So I really think we can learn how to maximize science by efficiently understanding how to do human-machine teaming. So I want to make the point that to me, that's very important, which is that this Moon to Mars strategy that we've been working on is really, really aimed at trying to figure out how to maximize the crossover. Now, it is true that Mars is a very different destination, but I think my point is everywhere is going to be a unique destination in the solar system. Instead, we need to develop a framework, this blueprint for how do we do this? What order do we do things in? How do we efficiently figure out how to operate those things? We can work the technical differences between the Moon and Mars. That's perfectly okay, because we're going to have to do that at every destination we go to. It's having this overarching framework that is so important. So this Moon to Mars strategy has been done in consultation with industry, with our international partners. We held workshops last year. We had a public comment period. I hope some of you contributed to that. And I'm excited that at the National Space Symposium, we will be rolling out the results of our first architecture concept review. Now, I'm going to set expectations here with regards to that. A lot of this was actually bringing about the whole agency together, all of the mission directorates, to talk about this Moon to Mars strategy and what needs to be in the architecture. We think that the objectives will be enduring. We will certainly review them as we learn new things, but what won't be enduring is the state of the architecture. The architecture will have to evolve as we have new technologies and new learning. We know that some technology will not work as well as we hope that it did. There will be new capabilities that come online. And so every year we plan to have an architecture concept review, and then we will have a public consultation period to go through and have inputs. In particular, one of the ways that we're communicating is there will be a series of white papers that talk about the trades, because I hear this all the time. Well, I did the math and the delta V for this and so forth. This is a systems engineering problem. So every single element of the architecture has massive trades involved and behind it. But we need to do a better job about communicating that, especially with our technical community, who can identify the flaws in our trades or remind us about new technologies, show us new ways of doing business. So I think that's the critical difference. We have been talking about this technical activities trying to get to Mars for a very, very long time. I think what's really different about the Moon to Mars strategy that we have now is that it's trying to bring across all of our stakeholders. We're trying to focus on science, national technical capability, and of course inspiration, which the great thing is that that comes with that, especially when you're sending humans, but also when you're doing world-class amazing science, as we have seen with all the things that we're doing. So we don't know, and we won't know if this is a politically resilient approach, but I think it's really important to bring the whole community along to make sure that all stakeholders are consulted. It's really important that you participate and keep track of this. I want to hear your good ideas. We will be rolling out what that consultation process looks like. I'll let you know this one is going to be really tight this year, and the reason why is we made the decision to try to work on a process for this architecture concept review and then rolling out the stakeholder reviews, discuss the architecture, and then start into the next rev. We need to get it aligned with the budget cycle. So our next ACR is going to be in November so that it will inform the following budget cycle, which is really helpful, but there's not a lot of time till November because it took us a lot of time to get to this first architecture. So I think we'll see a better cadence going forward, but I just want you to keep your eyes open for that because we really care and we want you to participate in it. I think we have to find a way to bring new ideas in faster. So with that, that was what I wanted to focus on today, was to talk about our Moon to Mars strategy, but I'm very happy to take your questions on anything you want to ask.
So we have have a microphone that will move around here for questions from the audience. And there are also people online who are asking questions.
Okay, great.
Okay, so let's start. So do you have anybody here who has any questions? Oh, right here.
Hey, Pam. Excellent talk. So my name is Eric, and I work in the mechanical engineering department. And I'm sure a lot of us here are working on really exciting, new projects that are hopefully aligned with Artemis and some of these future missions. And one of the questions I had to do with a lot of our technologies are probably like low TRL. And you just talked about how we're trying to accelerate or bring, technologies quicker into these space missions. Could you go into a little bit more detail about what NASA is trying to plan to do in order to, I guess you could say, alleviate some of the red tape from a technology perspective?
Yeah. Oh, it's worse than red tape, my friend. So it was very instructive for me to work at DARPA for 4 years because and we used to say technology transition is a combat sport. And it is indeed. There's huge barriers to technology transition, and often they are not actually about the technology. I think I'm really glad that the Space Technology Mission Directorate was formed in the Obama administration. Actually, Dava, where's Dava? Yeah, there she is. Thank you, Dava. Because having our own technology development organization inside NASA theoretically makes tech transfer easier. Theoretically, even in the Science Mission Directorate, which does tech development for science missions, it is still incredibly challenging. So for me, a key part was actually to bring the agency technical leadership together to have that discussion. You can understand the operational perspective of don't give me that, right? I'm trying to keep my astronauts alive. So I think we are just in the first stages of really trying to figure out and get people used to the idea we need to do a lot more tech dev. And, really interesting discussions actually with some of the stakeholders, for example, around nuclear propulsion in space. Well, you don't need a Mars transport vehicle until the next decade. Why are you doing that now? Well, because we have to do the development demonstration programs so that we can do an analysis of alternatives and have enough information. This is something that DoD does really well. They really understand that that pipeline has to exist. I think because, especially in human spaceflight, the scale is so long that I don't think this is a part of our DNA yet. So I think the big area that the administrator and I feel very strongly about is to grow STMD's budget, because they are where all of that tech development needs to be. And I'm pushing them to make sure that at least 10% of their portfolio is very low TRL. So that's just kind of a best practice across the federal government, that you have to have the tech investments in the very low TRL things. And about 10% is about right, because they tend to be lab demonstrations. And then you need to have the money to take it to a TRL 6 demonstration. So I don't know if that helps answer your question about what is that strategy.
Great,
Yeah.
Thank you. So do we have any online questions? No? Okay. Over there.
Hi, Pam. Nice to speak to you again. For those who don't know, my name is Justin Chiavo. I am a AeroAstro undergraduate senior. And what I want to know is, has NASA taken into consideration what they are going to do and how we're going to have a better architecture given the limiting factors of the launch rate of SLS, given that we can only send 4 astronauts per year? Yeah,
thanks, Justin. I think one of the things that's really interesting about coming into the agency is realizing that we actually have almost no capability to change anything in the next 3 years. What you're really doing is you're setting yourself up for the next decade. And so hopefully you saw that out of the Moon to Mars strategy. And the same thing is true of the budget cycle. I mean, we just got our 2024 budget that is not even approved yet. It's just the president's budget out on the street. So, we have the vehicle. We're focused right now on getting the flight rate up to a cadence of once a year. We think that's absolutely critical. both for making technical progress, but also for political resiliency as well. So that's the focus of our area. We're restructuring the contract for SLS right now. Interestingly, we do think that there are other customers. DoD wanted no part of SLS because they were afraid they were going to get asked for money. Yeah, so you know that, right? On the other hand, they're quite interested in having access to the capability once developed. So what we are hoping is that will enable us to make some investments in infrastructure, and potentially, theoretically, it's possible to launch 3 a year. Theoretically, it will take a while to get there, and we'll need the additional customers to make sure that happens. But we are working right now with industry to hand over SLS to become a service. Right now, there is no mechanism for DoD to use SLS because it's 100% NASA owned in the way it's structured. So having it spun off as a commercial service capability, we hope will enable us to do that more cost effectively. And of course, I think new technologies are certainly out there. I personally don't think there's anything that, it's ridiculous. We put a huge amount of investment in it, and we've proven that it's capable, and we're going to launch a crew on it. Nothing else close to that yet. So I think, as it happens, we'll have a concept review once a year, and hopefully new ideas will come forward.
Okay. Yeah, there was a question back there.
Thank you. My name is Dan, and I'm a graduate researcher at AeroAstro, and I wanted to thank you, first of all, for this inspiring lecture. My question relates to your chart on the why and benefits to humanity, which is a question I often ask myself. I'm curious how you see the exploitation of space research and microgravity research over the coming decade, considering that by 2030, the ISS is meant to be decommissioned, and Lunar Gateway is going to be significantly smaller. So I wonder how you see that sort of industrial exploitation of microgravity manufacturing and research.
I really didn't pay him to ask that question, but I'm super glad you asked. That's one of the other things that we're spending a lot of our energy on right now. So this is something that just isn't widely known. So thank you for the opportunity to talk about it. We are in the second decadal research effort or decadal study program for biological and physical sciences in microgravity. So that kind of comes as a surprise to a lot of people, how really focused we are on that science. We are actually just really hitting our stride in the science on ISS and what's coming from it, and some of the industrial research that's going on as well, which you don't hear as much about because it's proprietary and trade secret, but extraordinary work. So we're very confident that microgravity research has a long place, that there's a lot more work to be done, and we're just really beginning to get a hold of that. So ISS has been extended through 2030, but we're working with 4 companies right now for a commercial LEO destination. So I have to say, ISS was amazing. I mean, I helped build it, but we didn't know what we were doing. We took our best guess, and it was a prototype space station. And a lot of the technical capabilities on station are amazing, and we use them over and over and wish we'd done like 10 times more of it. And then there are things that just didn't work the way we thought they were going to. So we've learned a lot, and I think our focus right now is working with those 4 companies to transition that knowledge. And they're out there trying to raise capital, and we're getting some investment money as well to put into their activities to help them prepare for commercial LEO destinations. I personally think that Gateway is not an ideal place for microgravity research. It's a deep space research location, right? Things beyond low Earth orbit. So microgravity, you can get pretty close to home. The deep space is much harder to get. We should really be focused on the kind of research that can only be done in deep space and supports us going to Mars with humans forward in the future on Gateway. And that's why it's going to be much smaller.
Yeah, there's a question here.
Hi, Pam. Thank you for the talk. My name is Evan Kramer. I'm a third-year graduate student in the department, AeroAstro. My question is, in terms of Mars sample return, I'm curious about your perspective of the importance of simultaneously developing Mars technology, TRLs, while also trying to focus on lunar exploration, and what efforts are happening to make sure that TRL development for Mars exploration is feeding into TRL development for Moon exploration.
Yeah, that's a complicated question. As I pointed out, that the previous chart that I had, there are differences and there are strong similarities, particularly around infrastructure. I think the ISRU is going to be its own thing. Having said that, there's the foundations of ISRU is actually power. I mean, it is staggering how much power is needed for ISRU. So when I look at it as a tech dev effort, I mean, humans, we're operating space station on 110 kilowatts. ISRU, 2 to 5 megawatts. So a very, very, very challenging problem by comparison. So a lot of that foundational work is going to apply in both cases. And I look at it and say, without the power, we're not going to get any of those tech demonstrations done or have any of those capabilities. So for the near term anyway, especially with our limited budget, we're focused on those really big rocks, which most of them you see here. Without those things, we won't have the other capabilities that we need. It is very interesting. You may have seen that the Science Mission Directorate recently released a draft strategy for Mars exploration. So we went through a very interesting discussion about their Mars strategy and the Moon to Mars strategy and how they feed together. The linkage is really around the decadal survey, which really drives the Science Mission Directorate. Moon to Mars is very challenging because it's beyond a decade. And so that was actually part of what motivated them to look beyond a decade for their strategy. So we really see these two streams converging. I think the Mars sample return is critical to us because it will guide where we plan to send humans, I think, on Mars. So there is a lot of discussion in the agency about how to converge our science strategy with the human spaceflight strategy. I hope that helps.
Do we have any online questions?
Yes, I was just going to say, we have an online question who's wondering if the architecture review process will eventually be applied to other aspects of NASA, for example, aviation concepts that may benefit from further transparency and development.
Boy, if I had a nickel for every time somebody said, we love your Moon to Mars strategy, do it for everything. And all I can say is that it took like 100% of my time and energy over the last 2 years to get here. It's exciting to have the validation of the process. I think the key elements to it are around communications, around bringing unity of purpose inside the agency, but also in the broader tech community. And, strategy development is a unique thing. There's a lot of actually great, if there's anybody who also has a business degree, you know that. I see many strategies, quote unquote strategies, that are lists of good things to do. That is not a strategy. That's not how it works. So I do think that strategic thinking approach is critically important. I have to say, I am pretty happy and I'm very picky about this, with our tech strategy in both STMD and aeronautics. What I'm not as happy about, I think that got brought out, is how well we communicate about it. So one of the things that aeronautics is doing that I really like is building a community of practice around advanced air mobility. And through the workshops, the roundtables, and that kind of consultation, I think we're beginning to see a lot more of that transparency. We're going to extend that out for all the tremendous work that we're doing around decarbonizing aviation in aeronautics as well. But it is interesting, for those of you who are engineers, talking about communications is usually not the top of their list, but it's actually really, really important.
Actually, we do have a communications requirement for
Good.
undergraduates.
Glad to hear it.
Precisely so they can communicate.
Well, your pitch fest showed that it's working, so.
Any other questions?
We have a couple.
Over here?
Can you raise your
Right
hand
over
again?
all the way over there.
All the way over there.
Thank you so much for your talk. My name is Clara, and I'm an exchange student from Imperial College London. And so you touched upon a lot of interesting topics. My question pertains to the fact that there's a growing competition over what I would say is like a dwindling set of mineral resources out there. I mean, I think the semiconductor industry is pretty symptomatic of that. And all of this is happening against an increasingly unfavorable political backdrop. And so what I wanted to know is, how is that impacting design decisions, considering that pretty much every single space project is really a long-term project? You said that Moon to Mars was basically beyond a decade, so a lot happens in 10 years. Yeah. And yeah, basically, how is that getting factored into, I guess, the strategy overall?
Yeah, I think the short answer is that it's not. I would say, my sense of the aerospace industry writ large, as you know, electronics in particular are an area that is typically 4 generations behind what we use terrestrially because of the requirements for radiation tolerance and exposure and qualification. So I think the way we're addressing this issue inside NASA is really driven more by, I would say, the larger issue of global supply chain. So, what I discovered when I came to NASA is that we had different people thinking about supply chain. So we had the engineering organization looking at it from like a quality risk standpoint. Safety had their own lens, the same thing around counterfeit parts and things like that. I don't think we had a very consistent approach from a procurement standpoint. So we formed an informal supply chain working group just to enable awareness of all the different things that were happening at NASA around this. And we're also strengthening our relationships with DoD. Interestingly, DoD has different supply chain issues than we do. They tend to buy at much larger scale than we do. We have more one-offs, so we're thinking about that. We can often plan ahead more. What we have learned is we've been doing a good job inside the agency. Okay, this mission got delayed. We need this part that was purchased for that program, but they're delayed. Somebody else needs it now. We're going to do a swap across programs. The next step is to start doing that with DoD, where we're actually broadening that pool and that approach to it. We're also really finding out that a lot of the data is anecdotal. So we're building a single tool that will bring all of the information about the critical risk and so forth, and have that actually at the front end of procurement planning. So this is the dream. We're not there yet, but the dream is that we can actually project out our procurements over the next 10 years and say, maybe it would be better to do a bulk buy in a certain area for certain type of technologies. And get consistency for industry, which is really good for them, but also better planning for ourselves. Critical minerals is going to be really interesting long term. I think it's a great point. I think it'll take a while before it hits the space industry really hard.
Okay. Final question.
Oh, Jeff gets the last word.
Is it an astronaut question?
Well, no.
He's not going to ask me about flying in space. that I know.
Although I mentioned some people, I was on the selection committee when we picked you.
Oh, were you, Jeff?
Yeah,
I don't think I remember
and I'm
that.
glad. We made a good decision. But look, this has to. A lot of people ask me about, what are the Chinese doing?
Yeah.
Does it have an impact on NASA? I know there's political sensitivities, but I'm sure a lot of people here would love to hear your thoughts on that.
Yeah, I think, so for those of you who are not aware, there is something called the Wolf Amendment. It's a law that was passed that said that NASA can't work bilaterally with China except under certain conditions. And in fact, we are working bilaterally on a very few small number of things. One example of that is we are exchanging ephemeris data on our spacecraft around Mars to make sure that we are deconflicting activities around Mars. That's a great example. There's a barrier and a threshold that you have to prove that critical technology is not being transferred. But it does make it a lot harder for us to work with China. Obviously, we have a great and longstanding relationship with Russia and have since 1975, and that's in a very different place. I think there are challenges in that area. The difficult part for us is an extreme lack of transparency around what is exactly happening in the Chinese space program. I mean, you know NASA, you can go online and get information about anything. There's a lot of information out there about each one of our missions, and then we also have a commitment to open science and publishing our results and sharing them publicly, and sharing the data publicly, which is also, we don't find very many international partners that have quite the open science standards that we do. There's typically a period of time, at least, where it's protected and only the researchers from the country of origin get access to that data. And we feel, particularly in climate science, this is so critical. We need to get that data out to anybody who can find a good use for it. So that's probably one of the biggest barriers for us in working with, there's some really key philosophical differences. On the happy side, we have so many, we've got partnerships. I think we have agreements with like 63 countries around the world. So that's an amazing number if you think about it. And most of them are in science. But it is really phenomenal. And I think that is just critical to us going forward. If we're going to go out into the solar system, we're going to go as humanity. We're going to go as partners. We're going to go as representatives of Earth, not of any one country.
All right. Thank you very much for a great talk.